What's up, guys? We're going to be talking about a group of effects in Ableton today, and they are all modulators. So what you have to understand is modulator. So what does that mean? Well, that means is it has a gradual change over time. So I'm going to bust open the oscilloscope here, and we have a sine wave, and it is the simplest form of an LFO, or simplest form of an oscillator we can get, and in between this area and this area is the duty cycle. And if you have a shorter cycle, you have a higher pitch. If you have a longer cycle, you have a lower pitch. So if you have 20 cycles per second, you're 20 hertz, and that is, far below, well, that's directly below the audible range. And once you get down sub 20 hertz, then you are in the LFO range, and you use these LFOs to kind of automate certain ththings. So I'm going to give you an example. So we'll have our sine wave, just because, and the first one is our auto pan. Let me get my notes open here. It's our auto pan. So we'll notice that there is a sine wave, just like what we just saw, and it's running at 1 hertz, so 1 cycle a second. And we'll notice that it's going left and right, left and right, left and right. This sine wave, the orange sine wave, is the left channel. No, wait. Yeah, it's the left channel. And the yellow sine wave is the right channel. And we can see it's auto pan. So this is a tremolo effect, kind of, sort of. And we can adjust the rate. This is common in, guitar stuff. The phase means that we can adjust the phase. So that we adjust the phase, it's kind of like pulse width modulation, but a little bit different. We can adjust the phase of how these two line up. So if we line them up perfectly, we just get amplitude modulation, which is a little bit later in this video. Right? We can adjust the phase and all that. We can change the shape. So we have a sine wave here to a square wave. So it's variable to a square wave. Also, we can change the shape to a saw wave. Right? It's free running for now. It's always free running. A triangle wave. Sounds a little bit different than a sine wave. And this is called sample and hold, and takes a white noise and steps it variably, kind of like how we did with our bit reducing plugin. And what this does is, I'll turn the width off. So it kind of sounds like R2D2. There's that. I want to show you something else. Okay, so we have this LFO in stereo mode. So it'll start at the same phase, so it'll start at the same point, or it'll be kind of free running, right? Different kind of flavors for what you're doing. So we have something called a free running LFO, and we can have it between 0.05 hertz to 90 hertz. So anything past 20 hertz is into the audible range. Then you get something called frequency modulation. But this isn't frequency modulation. This is amplitude modulation, even though we're using AutoPan. We can sync this to 16ths, 1 bar, 8 bars. So think of it as like that sort of thing. And that's AutoPan, and you can have the phase of 180. 180 degrees means it's completely separated and mathematically sound. So this will sync with your DAW, which is Ableton in this case. All right, this is AutoPan. So we're going to go back to our auto filter. Now this is basically the same deal. We have an LFO and sample and hold type thing here. And what we can do is, yes, there's the rate again. So what does this do? Well, this modulates the opening and closing. I'm actually going to drop in a saw wave so we can hear the harmonic. So it's kind of wobbly. The shape is a sine wave, so we can see it here. The filter cutoff is being modulated. and we can have it slower. And we can increase the cutoff amount. And what we can do also is double up the filter and adjust the phase. You can't necessarily see it in the spectrogram here, but we're splitting the signal, doubling the filter, and then we're offsetting the phase by 183 degrees. So it's a kind of an autopan, but it's a filter autopan. We're getting kind of, hope you're keeping up here. And the envelope follower, we'll get to that later. We have different shapes. We have sample and hold. We have a downward saw, an upwards saw, or a ramp, triangle. We can sync this. That's pretty cool if you ask me. Alright, so we're going to go to our next guy. This is chorus. This is a classic effect. And what it is it splits the left and right and then offsets it. So we'll hear that now. You hear this a lot, and we can also, increase the feedback. Of where, because what's happening here is certain frequencies are overlapping the left and right, and they're giving us like a warmer kind of feel. You hear this in a lot of music. It's called double tracking. How like a vocalist will sing twice, and then it'll appear louder. This can also be modulated. So what's happening here is it's being stacked up, and it's being moved left or right. So it's offset slightly, but then one of them, they're each independently moving around via a rate and amount. So check this out. So this would be kind of spooky sounds. You can have it very, very slightly, like 0.1 hertz. So that's every 10 seconds you get a cycle. Yeah. So in the delayed signal, you can high pass. So you don't want like the muddiness on the bottom. This is what the high pass would be for. All right, we'll get into. We can have it fixed and all that, or you can have the delay completely off. Then you don't get anything really. You just get feedback. All right, that's chorus, and that's basically our chorus. Okay, we have our flanger. This is kind of the same idea, but we have more control of the LFO. So the signal is doubled and then delayed slightly and modulated. And the feedback is the amount at that like harmonic that makes it kind of neat. The delay time is set. Any more than 7 milliseconds, I don't think it really sounds good. It's kind of like chorus, but a little bit different. Right, so flanger is, quite popular. Okay, a phaser. Now I know my ABCs. There we go. A phaser. So what this does is this uses all-pass filters. It's just a bunch of all-pass filters, and depending on how many poles you have, depending on how many all-pass filters is. So what you're doing is just think of it as like a bunch of EQ peaks all lined up and like moving, and that kind of does really neat things to the phase. And yes, there's another LFO. So a lot of poles means there's a lot of movement. Sounds really neat on like white noise stuff. Just picture a bunch of filters with very tight peaks just moving around. So there's positive, there's earth, and then there's negative, which is a little bit different. It's just the inversion of the bell curve under the hood. Of course, you can feedback. You get a really kind of neat outer spacey sounds, and that's phaser. So the chorus, flanger, and phaser are all related, and that's why, you know, there's a lot of guitar pedals with those printed on it. Okay, frequency shifter. Now this one is a little bit more esoteric, but it's all good. So what this does, I'll do square, just as an example. Okay, so this is a frequency shifter, so it'll shift the frequency either by, you know, hertz or very fine like microhertz, so in the 0.1 range step, or, you know, the lot of hertz steps. And what it does is it basically shifts things up and down. So what you would do here, it'd be like a harmonizer, kind of like the Spangle type stuff. You'd have like a wet dry, so the dry signal mixed with the wet signal, and that shift, that'll take the dry signal and then shift it up a certain amount, and that would cause like a really interesting harmony that's used a bit, right? And that's your frequency shifting. So there's the fine tune, and then like the regular tune. You can shift the left and right kind of independently, so you'll have like a stereo splitting effect, kind of like unison. So if you do it that way, left will be 1.37 hertz, and the right will be 1.37 hertz. So you get like another kind of tremolo effect. That's why these plugins are all related, or these devices rather. And that's pretty fun. So we have another thing, and this is ring modulation. So what this does is, I will show you with a sine wave. Basically, ring modulation, it's amplitude modulation. So it's increasing the volume as a sine wave, so LFO, and it splits the signal and then takes the sum of the difference and then adds them together, and you get a weird effect basically. So right now we have 1 hertz, so that's 1 cycle a second, and you can kind of see it now. Right, you're modulating the amplitude with a sine wave. So you get even crazier, and once you get up to like the audible range, you get a ring modulation. It's called that because you would have 4 diodes in the circuit. This will give you a really kind of weird effect, and you can also give it some drive, because if, you know, the RMS, if you're lowering the volume, you know, if you're modulating the volume's actually kind of getting perceivably lower, so you might want to boost that. In the amplitude modulation, it's fixed. So 302 times a second, you have a sine wave modulating the amplitude. So you get weird sounds, and yeah, it's an old kind of effect. Yeah, so we have our LFO here, and this adjusts the rate of your frequency shifting or your ring modulation. Right, and yeah, that is all of our modulation. Autopan, autofilter, chorus, flanger, phaser, and frequency shifter. All good ways to make your sound interesting. There are a lot of them, yeah, pretty much all of them are considered retro effects, and they're, you know, you can build them with a handful of components, and they're used in guitar stuff, and yeah, I'm a big fan of them, using them in series and together, and having some overdrive and all that gives it a neat little touch for your tracks. But yeah, hope you learned stuff, and we'll be back shortly.